The power rule could be used in three different types of functions. So it's a polynomial, a radical, and a reciprocal. The polynomial is of the form x squared plus x plus 1, for example. Radical is the square root of x, the cube root, the reciprocal is 1 over x. X is the base, and then you could write the exponent as a number. That's what they all have in common. So we have the power rule, which we've sort of discovered using finite differences. So the power rule says that we have a function, base is x, power of a number n, and then when you take the derivative, that is going to be n, and then because you're multiplying the exponent to the coefficient, and then you're taking the exponent and subtracting 1 from it. So that is the power rule. So for example, how do we use it? So here's an example where we have d over d of x. We're used to Leibniz notation, which is dy dx. This is the same notation, and so that y is now written as the actual function. So the y and that y is the same. So what they're saying is you're taking the derivative of this function. So one of the things is that when you take the derivative, we're going to take each one separately. So the first part of it is going to be the square root of 2x to the fifth. This is a polynomial, not a radical, because it's the square root of 2 and the x is not under it. So when you take the derivative of that, that's going to be 5 square root of 2 x to the fourth. So you're subtracting 1 from that. The second one is not a reciprocal function because it's a 4 in the denominator. So that becomes 1/4 x to the fourth. It's just a coefficient. So when you take the derivative, it's 4 over 4 x to the third because you subtract 1 from the exponent. The last one is plus e. It is not e to the x, so it's not a function. It's just e. So we don't have that. It's actually to the 1. So this is actually a number, not a function. So the derivative of this one here, of any constant, which makes a horizontal line, slope is 0, is going to be 0. So this here gives us our derivative. So this is f prime of x, or the dy dx, either one would be right. Of this is going to be 5 square root of 2 x to the fourth minus 1 x to the third, and then that's 0. And so that is all we have to worry about. If you look at it, it's a fifth degree, went to a fourth degree went to a cubic, a constant went to nothing. Very good. An example here. So this one here, we're taking the derivative again, each one individually. This is a polynomial, so that's kind of easy. We know that that is going to give us 15x4, went from a fifth to a fourth degree. Now this one here is a little different. This is a radical. So when you have that, the coefficient is 2, and I need to change the x variable. That's still the base, and the exponent has to be a number. So that becomes a 1/2. So when you take the derivative of this, it's going to be negative 2 over 2, because this is over 1, numerator to numerator, denominator to denominator, and then you are going to subtract 1 from that, and so we end up with x to the negative 1/2. Then the next, so we did that one, and now we're going to do that one, plus the 7 is a coefficient. This here, we cannot have a variable in the denominator in order for us to do the power rule. Everything has to be in the numerator. So we bring that up, and that becomes a negative 1. And so then we are going to multiply this. This is going to be a negative 7 because we multiply those together. And then we are going to subtract 1 from it, and that's going to be x to the negative 2. So our derivative, dy dx, is going to be 15 x to the fourth minus 1 x to the, well, what happens here is that this one here is going to be over 1, And this is numerator to numerator. It's going to be a little bit, let me erase this here. So we are going to have, this is still going to be 1 there, but it's going to be minus. And so this one here is just going to be going down. And so I'm going to get 1 over x to the positive 1/2, which then is going to be, if we actually do the correct way, it's going to be over the square root. And then it's going to be minus, and then this one here is over 1, that's over 1. So we want to bring that down. This one stays in the numerator, and it becomes x squared. And so that is your answer. So there you go. That is your derivative. This one here, well, this one here is actually a product rule, which if you're doing the power rule, you don't know the product rule on there yet. And so we're going to change this to the power rule. So what we have here is we're going to have x to the 1/2 times x plus 1. And then we are going to distribute, and we're going to get x. So we have 1/2 plus 1, which is going to be 2 over 2. So that ends up having 3 over 2. So x to the 3/2, because when the bases are the same, you add the exponents, and then plus x to the 1/2. And now base x, number, exponent, and they're separate, we could take the derivative of it. So it's going to be 3/2 x, and then we're going to do 3 halves minus 2 over 2. And so what we get is 1/2. So it's going to be 1/2, which makes sense because we just did that up there. But just wanted to show you the work. And then here again, we're going to subtract 1 from that. And so we get x to the negative 1/2. And so back to this part right there. So you know, this one here is over 1 because it's this quantity times this quantity. So if it's a fraction, I make this a fraction to make it easier. So this one here is going to be 3 square root of x over 2. Could you have left it that way? Yes. But when we need to lower it down, you're going to need to know that. And so then this one here is 1 over square root of x. We could leave radicals in the denominator. That is fine. So my f prime of x is that. Okay, and this one here, this is actually a quotient rule problem, but we could actually, because it's only x to the 4th in the denominator, we could do this to make it a power rule. So what we could do is we could make it individual. And what we could do then, or you can make x to the negative 4 times x. Either way, you're going to get the same answer. So the next thing that you would do is you would have x squared, x to the negative 4, plus x cubed, x to the negative 4, and then x to the negative 4. And when you distribute, you're still going to get to the exact same thing. So here we get x to the negative 2 plus, in this case, x to the negative 1 minus x to the negative 4. Now we take the derivative and we subtract 1 from every exponent. And so you get x to the negative 3 plus x to the negative 2 minus x to the negative 5. So your derivative is x to the 3rd plus 1 over x squared minus 1 over x to the 5th. And we are good with that. And that is the power rule.